Well, it's the 31st of December, so the last day of 2024. Wouldn't it be nice if this Maxcom 4E could be done in 35 minutes? It's come with the correct power lead. We do have these available. We've got the connectors available. They're all genuine items. They're not new old stock or anything, because it's a currently manufactured part which Maxcom would have bought in at the time. So, it's for an end user. He sent 3 radios in. Just feels a little bit loose, so if we've got a screwdriver, type precision, otherwise when Mr. Chippie gets to do the scratchy corner test, he'll go, are you sure that that connector's okay? Right, he has sent mics in, but we'll use a standard replacement mic for the repairs, and we'll test his mic at the end. When you buy a standard replacement mic with a 5-pin DIN, this is the radio that it's intended for. I've had people hoping that it fits the Barracuda, or hoping it fits the SMC Oscar, or hoping it fits the DNT. These fit Maxcoms. Right, we'll power it up, and it's come straight on. We can hear our signal generator on all 40 channels. So I'll just I'll just put the signal generator on frequency, because it's very close. That's probably why we can hear it. Right, turn the signal generator off. That's interesting. Why is it going on and off? It's probably got the power lead wants plumping up as well. This is why I like people to send power leads in. Right, we'll open it up. You know what? We won't. I'll just take that. I'll take that screw out. We'll go through everything before I open it up. So, picture in picture on, in the place I want it. Transmit. Whoa, 3.9 watts. Channel 40, 4 watts. Channel 1, 3.8 watts. It's normally the other way around because it's easier to generate the lower channels than it is the higher ones, so it's a bit out of balance. So go back to channel 20, 1.05 amps. I mean, everything so far is fine. Let's look on low power. It's doing 270 milliwatts. And the deviation, for what it's worth on this test set, wallow, 2.2. Which is exactly the way it won't be doing the VCO. I've explained why, and it's working on all 40 channels. So is it anywhere near on frequency is the next question. Put the frequency counter up. 27,79112. It's virtually spot on. And we'll look at receive. So plug the test instruments into the aerial socket. And while we're at it, we'll plug the PA speaker into the PA socket. Right, we'll test PA. Testing 1 2, testing 1 2. They're weird, these, they come through both speakers, which is not desirable, but that's how it is. An extension speaker comes through both sockets, also not desirable. But it's quirky rather than, or lack of thought at the factory. Okay, so let's have a look at the cyanide meter. Oh yeah, it's excellent. 0.57. So this exceeds the manufacturer's specifications without any intervention. 0.5. 0.9. See if the squelch is any good. Turn that to full. And we'll now fiddle with the signal generator attenuator and see where that comes in. I want it to be 100 microvolts, but there's no hard and fast rule on that. 3, 10, 30, 100, 300, 1 millivolt. Yes, what? 100, 300. It's coming in at, oh, it's like 3 volts. Yeah, that's not good. Right, let's just do the other side, see how sensitive the squelch is. That's fine, it's 0.7. So, try not to clunk the microphones. We want 100 microvolts on the S meter at that point. Now these sets aren't always adjustable. At the moment it needs a whacking great big, ooh, 3, it's 1, 720 microvolts, 720. I'm doing the wrong box. 720 microvolts. Meter lamp works, switches work, potentiometers work. There may be a rider that the volume control may be dirty. It's gone off again, so could be a dirty fuse holder as well. So on transmit, it's banging across to spot on 4, which is right. Okay. So if you just bought something like this on eBay, it's working great. But we can dust it around the edges and make it work a little bit better and consistently know it's calibrated. Now if he's sent 3 sets in and he's not quite sure what's what, another Maxcom 4E, and there's a Fidelity 2000 he says, which should be absolutely brilliant. I don't think we're going to have to detach the speaker this time. I mean, considering this is 40 years old, it's like new. There's no capacitors lurking, and I've shown you before, you know, if I get the fiberglass brush on one of these presets, these are silver plated. Look how the silver's tarnished. Now it doesn't matter because the surface of the conductor is on the carbon track, so I'm not cleaning it with that. But I just want to show you these are silver plated presets. You know, considering these at a time could be had for $39.99 if you shopped around. Some jolly good parts. So I can't see any messing abouts, and here we go. The test gear's been warmed up now for about 90 minutes. I'll just switch the other test set on so we can do the deviation properly. We'll start by putting it on frequency. Just put it slightly high so that there's some leeway because they drop with age. Right, we'll run through the transmit. This could be the quickest one this year. The centre of the peak, so I wasn't quite there, which is why it was a bit lopsided. That was spot on. That was spot on too. That was spot on. That's a lid. That was a bit out. So now we'll set the power with this one, which is how it's supposed to be. And there we are, 4 watts. Now go to the channels, and as before, I mean, it was within 0.1 on the other channels, but it wasn't in the centre. So we've got 3.9 on channel 40, which is exactly what we'd expect, and 4.05 on channel 1. .05, 4 watts and 3.9 watts is exactly what you'd expect. Let's go back to channel 20. It's now 1 amp. So we're getting 100 milliwatts more and drawing 50 milliwatts less power, which is nice. So the power for the meter, it's spot on without any adjustment. Remember, this is into a dummy load. These only ever going to read how they were set into a dummy load. You can't put it on an aerial and say, oh, it's doing so many watts. It doesn't work like that. You can only read it on a dummy load. Then low power is now 290 milliwatts. Here's the preset for that. So we'll bring it up to 400 milliwatts. That's dirty. There we go, that's 400 milliwatts. At this point we ought to do the deviation, but we're not going to because I only put the test set on a couple of minutes ago. It needs 10 minutes to stabilise. We know that's correct. So receive, turn the squelch down. Got a dirty volume control. See if I can do it with this lid. I'm going to turn the power supply off because I want to waggle the control around to get that in. And hopefully, power back on. That's nice and smooth in operation. Right, we'll start with the detector. So we'll put 100 microvolts on the signal generator, and we'll show you that on the oscilloscope. Just put the volume such that it's a sensible trace, just the detector. Minutely out. And now we'll start with doing the sensitivity, etc. I'll start with the front end. I don't think it's been messed with. So we'll drop the signal. So we've got about 4 or 5 dB on the synod meter, so we're not saturating the receiver. That was at the correct place. Now these ones towards the IF. Put a bit more signal on for the next one. I mean, everything there was as it should be, so what I'm doing is just skirting it around the edges. So let's see what we've now got. Now we know it's absolutely at peak. It's just under 0.5, so we'll put 0.5 down. Not 0.45. Not 0.76. So we'll set the signal generator for 100 microvolts. and see if we can set the meter up. At the moment it's reading S5. So where's this? Yeah, it's got a preset on the back of the meter on this version. And there we are, we've been able to set it for the correct position, 100 microvolts equaling S9, which is how it is for a CB radio in the UK. Not how it is for a ham radio, in which case it's about 54 microvolts. So that's now set. So if we can do the squelch, let's put the squelch to full on the radio. So I want the squelch to be in at 100 microvolts and it isn't. So we'll adjust the squelch preset, which is one I was cleaning without adjusting it. Wrong way. So it isn't going to open at 100 microvolts. So there isn't a hard and fast rule on this. So I'm now going to put the signal generator on 300 microvolts. Is it going to open at that? Nope. I don't know which is. There we go. So I've put the signal now to 1 millivolt and it's open. So let's see if we leave it at that position, which is full, minimum sensitivity. Let's see where it is. So it's 480, is that 20, 40, 60, 485 microvolts. And now, let's see where its sensitivity is. But it was already okay before, so it's going to certainly be okay now. So that's threshold set on the radio, signal generator on. It's coming in now at 0.55. Right, swap over to the other test set. We'll see whether that's warmed up sufficiently. I'll turn this one off, save some electricity. Yeah, so volume control dirty, which would have made intermittent receive. Wow. Right, well, I'm going to come back to that in 10 minutes, because at the moment that's reading iffy. What I will just do, here's another just in case, turn the power off at the power supply. Again, this is why we ask people to send power leads in. It's possible that it's dirty, so just run over this with a fiberglass brush where it's there. The other side, the fuse. Right, so clean that up, put that back together, and that's another possibility. Right, we'll switch back on. We're connected to the test set. Let's see what it says. Wow. Oh yeah, it's 3.8, it's ridiculous. So it has had the screwdriver fingers in it. Wow. And there we are. I bet that sounded great on the air. Unless you've got a Fidelity 1000. Now 2.2 to 2.5. Good. We'll do both the mics the customer sent together. May as well do it on the other set, the next one. And we'll get this put together. I think that'll be his biggest complaint would be the fact the volume control was dirty. Reliable and competent is something I can say of this chassis. It's never going to be mind-blowing performance, with them suffering from desense on receive, which is where somebody on an adjacent channel causes the sensitivity to drop on the rest of the band. So not kind of like bleed over, but same effect. But these days it shouldn't matter. Right, same chassis used in the Midland Precision series, for those of you who don't know that. Right, we'll unplug that. We'll unplug the two things plugged into the speaker. We'll plug the aerial in. And we'll have a flick round. It's 5:15 and it is Monday 31st of December. No, it's not, it's Tuesday, isn't it? Yeah, it's Tuesday. 19 Roger, are we on low power? 19 Roger. 19 Roger. Roger. Nope. Good. Well, that's another set done, and that's your last one for 2024. So happy New Year, everybody! And tomorrow, if I actually wake up, I will do the customer's Fidelity 2000. Thank you for watching the Maxcom 4E from 1982.